A random website just ran a command on your computer. You didn't install anything. You didn't click a download button. You opened a page in your browser and a program already running on your machine did exactly what that page told it to. That's not a movie plot. That's a PlayStation in 2020. A $15,000 bounty. The desktop app ran a little WebSocket server on localhost and it never checked who was connecting. So any website you visited could reach in and run commands. You would think people learned. 5 years later, the exact same bug showed up in Cloud Code's editor extension, CVE 225-52882, a WebSocket on localhost, no origin check, drive-by code execution on a developer's machine. But here is the truth. People pull full RCE out of WebSocket and most hunters never even open the WebSocket tab. They test the app, they watch the requests, then they see 101 switching protocols, the traffic goes quiet, and they move on. That 101 is not where you stop, it's where the hunt starts. In this video, I will show you why this whole surface is a blind spot. Then we go fully hands-on in Caido, broken authorization, an IDOR that turns into a database dump, a GraphQL auth bypass almost nobody knows, and a web page that ends in a shell. So quick word before we start. My partners over at CSWSH just launched Agentic Pentest, an autonomous AI agent that go after your external assets and turns around findings the same day. If that is your world, the link is in the description. So this is AmrSec, go get your coffee ready and let's dive in.
The channel has enough content.
As this is
Like look download that in Let's get the model first, because everything we do later hangs on it. A normal HTTP request is one and done. You ask, the server answers. The conversation is over. Every new thing you want, you knock again. A WebSocket throws that out. It opens one connection and keeps it open. And once it's open, both sides can talk whenever they want. The server can push to you without you asking. That's the whole point. It's why your chats updates live, why a trading dashboard texts in real time, why a collab doc shows someone else's cursor moving, notifications, multiplayer games, GraphQL subscriptions, all of it rides WebSockets. So how does it start? It starts as a totally normal HTTP request, a GET with one special header. Upgrade WebSocket. The server agrees, sends back 101 switching protocols, and from that exact moment, the conversation stops being request and response. It becomes an open pipe, both directions, until someone closes it. You will see a header in there called sec-websocket-key. Ignore the name, it is not authentication. It's a handshake formality to prove both sides speak the protocol. It protects nothing. And here is the one fact that breaks this entire surface wide open. The same origin policy. The rule that stops one website from reading another website's data does not apply to WebSockets. Sit with that. The protection you lean on everywhere else just is not here. After the upgrade, the messages flying back and forth are usually JSON, sometimes binary. They look like little API calls because that's exactly what they are. Picture your normal workflow. You are proxying a target. Requests are streaming into your history. Your scanner is chewing through them. Then the app upgrades to a WebSocket. The request count stops climbing. The scanner has nothing to say. It looks like you hit the edge of the app. You just didn't. You hit the part nobody guards. Think about where companies' defense actually live. The WAF inspects HTTP routes. The CSRF token sits on HTTP forms. The access control middleware runs on HTTP endpoints. Almost none of it wired into the WebSocket message handler. Bortoswogger says it plainly. Most testers give up the second they see that 101. And it gets better. On most apps, authorization is checked one time at the handshake. Once you are connected, the server trusts the pipe. It does not recheck who you are on every message. So every single frame you send after that is its own little request, and almost nobody tests whether that request is actually allowed. And that's the price, not some exotic WebSocket only exploit. It's the normal bugs you already hunt, IDORs, injections, broken authorization, sitting in the frame that no tool and no hunter ever looks at. So here is the recipe you are going to run on the lab and on every WebSocket target you ever touch. 5 steps. Discover the WebSocket, recognize the 101, model the auth, handshake or per message, filter the noise, then replay or edit single frame. And keep those 5 in your head. Now let me show you what they actually look like in Caido. Here at the target, I built a small app called Support, a team operation dashboard with a supported chat bolted on, live matrix, messages, documents lookup, admin controls, and the whole thing rides on WebSocket. That's on purpose. It means every bug we find lives on the same stream you are already watching. It runs at my local domain and I'm logged in as the lowest privilege account on it, regular user. Everything from here I do as nobody. Now, before I throw a single attack at this, 2 things. First, I just want to use the app like a normal person and watch my own traffic, so you see what healthy looks like. Then I will walk you through the exact tools we are going to live in for the rest of this video. If you have never touched a WebSocket in your life, don't worry. I will explain each one as we use it. So let's open it up and click around. Alright, so this is my app right here and my browser is proxied through Caido. So if I open Caido here, you will see that I don't have anything. Now I will get back to Firefox, hit refresh and back to Caido, and now you see we have traffic here. So what I will do is I will just log in, and here what I will do is just using the app like a normal user. Here I am logged in as the attacker. Here in the dashboard you can see we have live activity, we have announcement, and we have some metrics here. If I go to documents, I will see that this is my document, and once I click on it, it will view the document for me. And here we have chat as well, so let me write something like hello world, and as you can see here, attacker sent this. Let me send another one like AmrSec. So here it is sent. What I'm doing right now is just exploring the app as normal user and getting some traffic on the wire, real traffic. And I just explored all the app, logged in, checked out everything, and that traffic has to land somewhere, and that somewhere is our first tool here. I will get back to my Caido here, and you will see that we don't have that much traffic in my Caido. Let me make Caido a little bit bigger for you, and now you can see it's only like 7 requests here. But actually all these requests is in our first tool, and our first tool is the WS history. I knew this because in my HTTP history I can see 101 requests, and here the first 101 here, the second one is here. And that means it is switched the protocol. So now I will go to the WS history. This is the record of every socket Caido has seen. One row is one connection, and if I click on it, on the right side I have every message that wrote it. The arrow is the direction. To server is me talking. To the client is the server pushing back. And here all the messages are just read only. This is the tape, not the place we tamper. And when you are dealing with WebSockets, the live stream gets noisy very fast, and we have to filter them the right way, and this is where the tool comes in. And this tool, it's not actually a tool, it is StreamQL, completely new to Caido. So StreamQL is the filter language for sockets, the same idea as HTTPQL on the normal HTTP traffic, but here we have 2 namespaces. First namespace is WebSocket for the messages and the stream for the connection. And right here I can do something like creating a new query for the stream. That host of it should equal my host for this lab. And once I do this, here you will see it is filtered. I'm already using a scope here, so there is no change. But you have to know that you can use it here, and it even takes rejects. So later I can sweep every frame for a pattern in one query, which is awesome. But here, reading the WebSocket messages is the half of it. The other half is changing a message, and Caido gives you 2 ways. The first way is live in the moment, and this is where the third tool for WebSocket comes in, and it's intercept. Intercept here have intercept WebSocket, and if I just intercept all the WebSocket and change it forwarding to B, queuing, you will see that right now we can intercept all the WebSocket messages. So intercept catches the message mid-flight, so I can change it before it ever reaches the server. You reach for this when the timing and the order matters. Here I will just stop queuing and stop intercepting WebSockets. And the second way to change a message is the new one. Honestly, it's the reason I wanted to make this video right now. And it is the last tool we have, which is Replay WebSocket. WebSocket Replay takes the upgrade request and opens its own fresh connection and lets me edit any single frame and fire it over and over. And this is Replay, but for WebSocket. It's just shipped in Caido, and before it, testing a socket meant fighting your tools. Now it's edit and send. So here, let me show you this really quick. What I will have to do is come right here, and in the split button, I will choose new WebSocket session like this. And here you can see there is no connect. So connect is disabled because I have to add my upgrade request. Here, I will get back to my HTTP history, and here is the request. We have the stage 101 switching protocols. So I will just copy all of this back to my reply, paste it here. And now we have the upgrade request. Do not forget about the terminators. They are very important. And now I will just copy the host, paste it here, and I will have to make sure to remove one S of WS because this is HTTP. Once I do this, connect will be enabled, and if I click connect, you will see it is connecting right now, and now it is connected because we have this indicator here, means this socket is live now. I can send and receive messages. So that's the whole kit. History to find the traffic, StreamQL to filter it, intercept to catch it live, replay to craft and fire. And from here on, every single thing I will do is one of those four. And I will cut out which one each time so you can follow along on your own target. Now let's actually break something. Alright, so I will close this connection here because I don't need it anymore. And now let's talk about our first bug in this app. And the first bug actually is the cleanest proof of this whole idea. We have to go back to the recipe for a minute. The auth got checked once at the handshake. So my question is simple. Now I am connected. Will the server take a message? It should only ever accept from an admin, but to send an admin message, I first need to know what a message from the admin looks like. And here, I don't guess, I read the client. And to do this, first I have to learn the shape of these WebSocket messages. I will get back to my WebSocket history here and make this a little bit bigger for you here. And now I am on this connection, and here I can see messages going to the client. So I have to see what these messages looks like, and here these are all just metrics, and I want to exclude this at all. So I can come right here and write and the WebSocket message dot row, so all the row content shouldn't contain metrics. Okay, it is metric, not metrics. So let me filter, and now we don't have any metrics. Here you can see to the client, we have here the message, it's just a JSON, and we have here type, chat history, and then the message data. So if I come right here, all the messages are just JSON and they have this type, right? So that's the message skeleton, a type plus some fields. Now I just need to know the types I'm not allowed to send. For example, if I go to the client here, you can see we have type chat.history. To server, we have chat.history as well. And here we have another type that's document.list. So those are my types. Now it is the time to see the types I'm not allowed to see. And the easiest way for me to do this is just go back to my browser here and open the DevTools here. And I read the client-side code. So if I go to debugger here, I will see we have the sources and we have the bundled JavaScript file here. I can just go to search and search with something like type. Okay, and now we have 19 matches. So if I click on this one, you can see here we have the header content type. That's not what we want, but here we have if the name equal documents, the type of it will be document.list. And that's what we want. So let me dig deeper. Here we have chat.history. Let me just search with this since it all follows the same way. So I can come right here to this one. The second one is a chat history. Third one is metrics.subscribe. And we have history again. We have a chat.send. And here we have admin.broadcast. So this is the type that I'm not allowed to touch. And here we have admin.setMode and all these other types. They aren't for me. And here you can see in the comment it is admin UI. So my account doesn't see the admin panel. The UI hides it. But the code that drives that panel still ships it to every browser, mine included. So now I can see we have admin.broadcast, admin.setMode, and ops.run diagnostic. I didn't invent these, the client handed them to me. So the UI hides the buttons, it doesn't hide the code. Now let's start by building a very cool attack from this. I will just make this smaller here and I will get back to my dashboard and I will go to my Caido and go to the HTTP history. This is our upgrade request since I already have it there and it is connected. I don't have to reconnect it again. Now I will just move my camera here to be able to see this send button. And now if I go to the HTTP history, go to something like the message. I just want to see how we pass a string. So here we have title and text. Okay, that's confusing. Let me get back here to my code and see it here. All right, and here I found the name of it. It's called payload, which is really weird. But let me come back here to my Caido, copy this message and go to reply. And here is the thing. Now I didn't send any messages yet. So I will just paste this here. Let me remove all this stuff because I don't want them, and close this as well. And here we have the type and the title. So for the type, let me get type from here. I think it was admin.broadcast here. And you will see that here we have the type admin.broadcast and it needs a payload here, which is text. So I will copy this to my Caido here to be this type, and instead of title it will be payload, and here I will add, for example, this is attacker message. Okay, and once I click send here, you will see that the server pushed back with type announce with this payload. So that's properly announcement. Now if I close this, you will see here that in announcement attacker sent a new announcement, and this is admin only action. So that's why this worked. I took a frame that the server already trusts from me, swapped it in an admin type, I pulled it straight out of the JavaScript and fired it, and it went out to everyone. The handshake was the only door and I walked it through. Every message since has been on the owner system. And what we can see here is broken function level authorization living in a WebSocket frame. The server checked who I was exactly once, and when I am connected, it never check again. You have to hold that because the next bug takes the same gap and turns it into a database dump. Now, the next bug we have is the one that I really want you to watch. It starts at the most boring bug in the book and ends with the whole user table. One field does all the work. So if I come back here to my browser, I will see something really weird in the documents. Obsport here lets you open a document over the socket, and the message is simple, a type and an ID. So I will just come right here, get back to my Caido, go to intercept WebSocket, get back here to the document and click this one. Let me refresh and click this one. And I forgot to turn on the interception, so I will just do it again. And here there is no documents yet because I'm intercepting the traffic. So let me just get back here, and once I click on it, you will see that the message here is intercepted, and this one is our message. Here we have the type document.get and the ID of the document. So I will copy all this message and just stop interception. And what I will do is just sending a message with this one. It's supposed to return the document data, and as you can see here, it does this because here we have the document ID, the title and the body of it, and the owner ID, which is me in that case. So what I will do, the most boring and first thing you will think about once you see this is just replacing the ID with another document ID. And here I will do this, and now I have a new ID of document. And if I send this, you will see that right now it is another document because it is another title, and yeah, it is another owner. So this is not my document because I cannot see here as well. So now there is no ownership check. I asked for admin's document by ID and the server handed it over. And that's IDOR, same bug you will find on an HTTP endpoint, except it's hiding in a frame nobody inspects. Now the wall is what makes this interesting. Here is a catch. If you take a look on this ID, you will see that this ID of the document is huge and random. I can read a document if I know its ID, but I cannot guess them. It's high entropy. So most hunters stop here and report as medium, but high entropy is not authorization. It just means that I need a list. So what I will do is I will try to send the message again, and this time I will just add a single column here. And once I send this, you can see here we have an error with a message with it. Once I add a single column to the document ID, it drops straight into SQL query. One quote, and the Postgres throws the query right back to me. No parameterization, it's injectable, it talks. And now, since this is injectable, I can add my payloads. For example, I will add here my base message here, but instead of this ID, I will replace it with my payload. And here is my payload. As you can see, the ID is just opened and closed. After this, I will cast select email from users where the role is admin and limit only to 1. So once I send this, you will see here it says invalid JSON. This is normal. Let me try again. Alright, and remove this bracket, send it again, and now you can see it returned an error, and this error returned the email of the admin. I can do the same to, maybe I can just remove this where and remove the limit as well. And now if I send this, you will see here it shows only one row. Since it's replying, I can use something like this. I'm selecting all the IDs of the documents from the admin. So if I send this right now, it will just give me back a message, and this message have all the IDs of the admin documents, right? So now I will just use these IDs to get the documents of the admin to complete the chain. So here is the base message. I will just replace this ID with one of those admin IDs. In this case, this one, for example, once I send it, it will return the admin document here. As you can see, production DB credential, and we have here the owner is 1. And that's the chain closing on itself. The injection handed me the IDs, and the IDs unlock the IDOR. The wall that stopped everyone else was the door. And that's the whole shape, an IDOR in a frame that pivots into error-based SQL injection over WebSocket is real report. It paid $2,000 earlier this year. The bug was never exotic, it was just somewhere nobody looked. Next one is for the people who think they know GraphQL. This isn't GraphQL, listen, GraphQL is just the passenger here. The bug is in the WebSocket underneath it. When an app runs GraphQL subscription, they write a WebSocket. And there are two different protocols that do this. With the naming trap, that's almost cruel. The modern one is called GraphQL-transport-WS or WebSocket. The old legacy one is called GraphQL-WS. Same words, different machines. So here is Perl 1. The client picks which protocol through a header on the upgrade called sec-websocket-protocol, not the server. Perl 2. Servers almost always leave both turned on for backward compatibility. So the week-old handler is sitting right there, even though the real front end never touches it. Perl 3. The modern handler gets everything. You have to send connection_init. Get an ACK, and only then you can ask for data. The legacy handler is at least one popular framework. Didn't. It would take your subscription before any auth ran. Now I will get back to my browser here and make sure I am good. Everything is fine. Live activity is loading, no announcement, and all good. And I'll be back to my Caido. Stop or close this connection since I don't need it anymore. And here, if I get back to the HTTP upgrade request, you will see that here we get /WS, which is WebSocket. And this is the upgrade request, and here is something. If I get back to my HTTP history, you will see we have here the current upgrade request that I used until now, and we have another one which is called GraphQL-WebSocket. And here it is completely different WebSocket, so I will just copy all the upgrade requests here. And before I go to replay, I will just go to WebSocket history and see what this looks like. So here, if I open this connection, you will see I have nothing right now because I'm filtering for the messages that have error. If I hit enter and go to this one, you will see here we have the messages, and these messages here start with this message. We have the type connection in it and the auth token, and then we have connection ACK, and then we have the subscribe directly. So what I will do is I will get back to my reply here and create a new WebSocket session, and in the upgrade I will paste my upgrade request, copy the host, paste it here, and remove the S. And that's not only it. What I will do here is I will change this SEC WebSocket protocol. Right now it is GraphQL-transport-WebSocket. So now I will just remove transport and one dash, and I will just return it to the legacy one. And here this will just skip the connection in it entirely. So if I click connect here, you will see it is connected here from that indicator. And now since this is the legacy one, I will just send the start frame straight away. And once I send this, the server will reply, and here you can see it's sending me data. So no init, no ACK, no session. I forced the app onto the old handler and subscribe to the admin alerts, and it is streaming right now. That's an auth bypass, and it's real CVE, by the way. And now I stop it. If I come back to my WebSocket history, you will see here that it didn't start the same way I did. It first sent connection in it with my auth token, then the server replied with connection ACK, and then only the client was able to send GraphQL requests. Okay, so now I will get back to my replay, come to the HTTP upgrade request, and just restore the modern path, and here I will just click connect. And once I click connect, you will see it is connected, and now it returned timeout. It returned 8. So what I will do is I will click connect, and here send this message very fast, and here I tried to skip the ACK, and as you can see it returned 1. So what I will do is I will try to connect again, and here I will send a message with tampered auth token, and as you can see here it returned an internal error. So here is the thing, when the error is 4401, there is a real gate before the ACK. When it's 4403, that means the auth is enforced and I failed it. And when it returns 4408, that means you never sent the init in a time. And this is what happened when we just connected and left it for 3 seconds. It returned 4408. And those numbers map how the server actually thinks before you even land the bug. And here, if I just remove this completely and connect again, I will just skip the init, right? But here is the thing, the GraphQL HTTP endpoint have the introspection disabled. But here, if I try to send the GraphQL introspection query like this one and send it, you will see that the server returned like that's too long, but it returned the schema, okay? So here it is, and I can make it even bigger by getting every type argument or enum. And if I did this, it became even longer, as you can see here. So that's introspection. As I said, it was blocked on the HTTP endpoint, but it's just the pre-transport settings, and they forgot the socket runs on the same schema. The whole map of the API handed over the channel nobody watched. And to be clear about the tooling, because it matters, all of that was by hand in WebSocket replay, editing the upgrade, dropping a frame, firing a row subscribe. For the normal HTTP GraphQL, there is the GraphQL Analyzer plugin. You right-click a post request and it pulls the whole schema by introspection. But that's HTTP side. Over WebSocket, there is nothing like this for now. You craft the frames yourself. And the move that matters here is the client picks the protocol and you pick the weaker protocol to hack on. And now it is the time to pay off the intro. We started with a website that runs code on a machine. So let's build that step by step on OpsBoard. Remember the one fact that the same origin policy does not cover WebSockets, so a page on another origin can open a socket to a site you are logged into, and the browser attaches your session cookies as long as the cookie is the same site. My attacker page here lives on evil.amrsec.lab. Okay, Claude did this very well. It is my evil page. It is a subdomain of the target, which is AmrSec.lab. It is same site, so lacks cookies rides along. It's CSRF, but on the handshake. The name is cross-site WebSocket hijacking. Keep that same site detail in mind. We're gonna come back to it in a minute. Now, if I view this page source, and you will see here in the script we have a lot of stuff, but what matters here is the part that creates a new WebSocket here. And here, if I scroll down, you will see that we have a new WebSocket here, and there is an on-message handler that logs every inbound frame. So what I will do is I will get back to my dashboard, log out here, and looking at the admin, which is Alice. Now, once I'm logged in, what I will do is I will come back here to my evil page, and I will click Open Hijack Socket. And once I click this, you will see here that we have some logs. And in these logs, we have the private frames of the admin, which is Alice in that case. So my page just opened an authenticated socket at the victim. No phishing form, no token thief. The browser attached her session because WebSockets don't get the same origin policy. And my page is same site. And because the pipe is two-way, I'm not just sending, I'm reading her data back out. That readback is the part most people miss. CSWSH is not fire and forget. You can pull data out. Now let's turn this into something worse. Here in the attacker page, if I click run diagnostic as victim, you will see that it is pinging here the IP I write. So I can drive an admin actions as her now. And this is because the run diagnostic is admin only that pings a host. If I come back here to the dashboard, ops console, you will see we have here run network diagnostic, and this is only for admin. And I was able to do this from here. Now, since I can just hand any IP, I can just add semicolon ID. And once I click run as victim, you will see here it is pinging and then return the ID of the current user. And the target goes straight into a shell command, semicolon ID, and the server runs it. That's the chain, a web page to a hijacked socket to an admin message to a command on the server. So honestly, I kept that sync fake on purpose. It pings localhost, it runs ID, nothing real, but the shape is exactly the getbot chain, CVE 2023-0957, where a cross-site WebSocket hijack ends in a full workspace takeover and got fixed in a single day. From a page you visit into a shell, and that's why I promised you in the intro. Now, let me be honest with you, because hyping a dying technique helps nobody. For years, CSWSH was easy money. Cookies wrote along on every cross-site request, so any page could hijack any socket. That era is mostly over. Browsers now default cookies to same-site lags, and the WebSocket handshake is not top-level navigation, so lags cookies don't get sent cross-site, and the lazy version is dead. But do not cross it off your list because it survived this in 3 real cases. Case 1 is same site cross origin. Same site is judged at the registerable domain, not the exact origin. So evil.victim.com still counts as same site to app.victim.com and the cookies flow. That's exactly what you just saw on evil.amrsec.lab to amrsec.lab. A subdomain takeover reopens the whole attack. Case 2 is cookies explicitly set to same site none. Plenty of apps still do it for legitimate cross-site reasons, and every one of those is back on the menu. Third case is internal and localhost services. Private network access is supposed to guard those, but it works through a coarse pre-flight, and WebSockets don't send a pre-flight, so that protection is just not there. That's a PlayStation Now and the Cloud Code class. It's still wide open. And it isn't theoretical in 2026. Dazzle and Nginx UI both shipped CSWSH CVEs this year. The catch is the payout. Public CSWSH bounties are modest, even a few $100s, because the conditions are narrow now. The real money on this surface is behind the upgrade, is in the per message authorization and the injection we did earlier. So test CSWSH, but spend your time where the frames are. We hit the main surface, but I want you to know how much further the rabbit hole goes, so you keep pulling on it. Race conditions. A WebSocket has no request and response pairing, so the server processes your frames concurrently by design. That makes sockets genuinely better for racing than HTTP for some bugs. The honest limit is you can't get the perfect co-arrival you would get from an HTTP2 single packet attack, so the timing is loser, but it is still a real edge. Next, we have WebSocket smuggling. This one attacks the handshake itself at the proxy layer, not the messages. Send a malformed version header, and some proxies keep a raw tunnel open that you can reuse to reach internal only endpoints. It's situational, it needs a specific setup, but when it lands, it's nasty. Next we have binary frames. People see protobuf or signed blob and they close the tab. Just don't. That's encoding, not security. Grab the schema, decode it, edit at the structured level, re-encode it. The bug is still in there. It survives precisely because everyone gives up at the wall of bytes. And there is more. Oversized frame denial of service. Message payload deserialization that has hit 9.8 criticals. I'm not going to walk every one of those today, but now you know they are there, and you know they all live in the same blind spot. So let's look at N. Remember the recipe. Find the socket, catch the 101, then attack the frames, because authorization stopped at the handshake and every message after it is a request nobody checked. Remember the 3 moves that did the damage today: a regular user sending admin messages, one ID field that went from IDOR to the whole database, and a web page that wrote a hijack the socket all the way to a shell. And remember the one line that it changes how you hunt. When you see 101 switching protocols, that is not the end of the app. That's the start of the part nobody tested. Open the WebSocket tab on your next target and don't quit at the 101. If you want me to take this live, a full WebSocket hunting session on real target, drop WebSocket in the comments and I will bring it. If you found this video helpful, do not forget to like, subscribe and hit that bell icon for more cybersecurity content. And if you have any questions, feel free to drop them in the comments below, or you can reach me directly on X. Until next time, stay curious and stay secure.